for positive definiteness of A matrix. Now if A is not a positive definite, then any vector U is in the null space of A, then you can find any vector for which A of U is 0, and therefore E will represent an infinite cylinder instead of representing an ellipsoid in n dimension. So you take any vector in the null space of A, you put that vector here, and now so if A is not positive definite, then any vector, then any U such that U is which is in the null space of A, if you put that vector here, then you can have a length along this direction and it will satisfy this quantity. Then if you try to visualize, then this will represent an infinite cylinder in an n dimensional space. Now this thing will be cleared in the upcoming lectures, in few of the upcoming lectures on geometrical analysis of path planning, in which I will again discuss this problem, and I will show you how to use it in path planning problems. Okay, so therefore this is a condition on matrix A, that it should be positive definite. Now this is a minimum volume ellipsoid covering the finite set, and this is the SDP semi-definite programming feasibility problem, assuming homogeneity and PQR before putting constraints on P as shown below. Find P, Q and R. This feasibility problem is for finding this ellipsoidal surface. So what we did was, we took these 4 points, and we removed them. We found an ellipsoid covering the set C, and we removed all the points lying on this ellipsoidal surface. Okay, we removed all the points lying on this ellipsoid. Now we are again finding an ellipsoidal surface that can separate the two classes, that is these two classes. We removed these 4 points, and now we will try to solve this SDP feasibility problem. Find P, Q and R subject to P is less than negative I, which is negative identity matrix, with subject to constraints X transpose Px plus Q transpose X plus R is greater or equal to 1, and Z transpose Pz plus Q transpose Z plus R is less than or equal to -1. So after removing these points, the two classes are now separable, and we get solution in the form of P, Q and R, and this is a discriminating surface. Now the two classes are separable. So the conclusion is, we had a data set, and on solving this SDP feasibility problem, we get that this SDP is infeasible. So what we did, we considered an ellipsoid, a minimum volume ellipsoid covering the set C, and we removed all those points lying on this ellipsoid. So we get two classes which are now separable, and therefore this SDP is feasible. We assume homogeneity in P, Q and R, therefore we put the constraint that P is less than negative identity matrix, and X transpose Px plus Q transpose X plus R is greater than or equal to +1, and Z transpose Pz plus Q transpose Z plus R is less than or equal to -1. So this is the ellipsoidal surface for separating the two classes. These were the points which are moved, and now they are considered as class B, and these are class A. These points are in class A, and now these points are in class B. So thank you for watching this lecture. And you have one more point, in 2D the surface is an ellipse. So I hope you enjoyed this video presentation or lecture, and thank you for watching. And this will form the basis of our discussion in upcoming lectures in path planning, which will be based on feasibility problem, that is quadratic programming, reformulation of non-convex problem into convex problems, and SDPs. So thank you for watching this lecture. I am Sanjeev from searching.com.